uniform rod of length 6 meter and mass. So mass of the rod B mg, I'll write it. So everything is liquid. Specific gravity, it is hinged at one end at a depth of 4 meter. Later on, I'll show that liquid. At the other end, a body of mass is placed on the rod so that the rod remains in equilibrium with full immersion. So the rod remains with one end just near the free surface of water. Mass m is not immersed. What is the value of m? Tell me like where the buoyant force will act. The buoyant force should act here. We don't know this theta. Okay, let's see what we can do. And we know length. This is L by 2. L by 2. What are the forces that are acting? Let's see that. A reaction at the hinge will come. So if you want, you can calculate that reaction at the hinge also. Let's get into the thing, that one. Can we equate forces? If we equate forces, what is the problem? Ry plus Fb minus mg minus m1g equals 0. So what is the thing? We know buoyant force. Huh? There's no problem with this. This m is unknown. We know m1g. We don't know ry. That's why this equation will not help us. Shall I go for torque? I'll go for torque. So what is the expression for torque? Net torque about O should be 0. This is C. This is A will take it. So net torque about 0.0 should be 0. All will set up torque, the weight, m1g L by 2 cos theta, clockwise. Then buoyant force, Fb L by 2 cos theta. Why buoyant force should act here? Why exactly opposite to the weight of the rod? Why not somewhere here? Because full length of the rod is immersed. Can you recollect? Now the total length of the rod is immersed, so therefore buoyant force will act through the center of buoyancy, where the center of buoyancy now will be the midpoint of the rod. If the half of the length is immersed, then the center of buoyancy will come at L by 4. I think yesterday we discussed one problem. Please do compare. So then this should be equal to, then due to weight, mgl cos theta equals 0. Anyway, like a L will get eliminated, cos theta will get eliminated. So m1 by j anti-clockwise, fb by 2. So this is clockwise minus mg equal to 0. So we know weight of the rod 1.5, 10, 2. Buoyant force, density of water, AL G by 2. This mg, we don't know. Okay, the G also gets eliminated. Okay, this will become minus 3 by 4. Rho W AL by 2 minus 3 by 4 equal to M. We don't know area of cross section of the rod. We don't know area of cross section of the rod, no? How to this? So let's come for this one. Mass he has given. Mass, density, what you can write. Specific gravity is given. First, what is specific gravity? 0.6 equal to density of rod. Let me write sigma. Sigma by rho W. 0.6 rho W. Then how you define mass? Density is equal to mass by volume. Mass by volume. So what is now A? You can write it in place of A. You should write it as M1 by sigma L. You see that it will become very simple. Further, or directly AL you can replace it is here. Directly AL you can replace. Just some calculation, nothing. M1 by sigma. What is further? Sigma you can add 0. M1 we know. Sigma what you can add 0.6 by rho W. So AL into rho W, what you can write it as? Substitute that M1 by see all some small observations which you have to make it. So value of M1 we know 1.5, substitute that and solve, you get the mass of the particular block. So that center of buoyancy, are you getting now? Total rod is immersed, center of buoyancy will be center of gravity. If 1/4 half of the rod is immersed, then center of buoyancy will be at L by 4. So for rod, okay, we are able to tell. For different shaped objects, center of buoyancy calculation again will be very difficult. It's not a part of syllabus. That's why I just took only simple cases here. Now, after getting the value of M, substitute here, then you can